everybody. So, welcome to all my programming friends, and I am very excited to start with this new video. So, you have gone through my previous videos, and I have received all the comments and likes for my previous videos, and it really encourages me and gives me a lot of motivation to continue this journey of doing research in this topic of LLMs and AI and posting new videos. I always try to post new videos quite frequently, like on every single day. I try to create a video, but this is a very like it's still relatively a new topic of LLM and AI. So I have to spend a lot of time in understanding and in learning about the AI and about the LLMs. Still, many of the features in this LLM industry or LLM field are still in the experimental stage. So it really becomes time consuming to do research and to figure out different ways, and even like I also try my best to not only give you an understanding but also give you a demo of some of the understanding which I have obtained. So that is the reason it takes a little bit more time. So I had received a comment on my YouTube channel regarding about myself, like giving an introduction about myself. So I will only take a couple of minutes to introduce myself, who I am, and what motivates me for creating these videos, what is my background. So basically, you can see me on my LinkedIn page. I will be sharing all the links to my profile and my background in the video description. So basically, I am an independent full stack developer, senior developer, and solution architect. I have more than 18 years of experience in working on all the platforms ranging from web, mobile, software, databases. I have worked on technologies like .NET, Nest, Node.js, Python, React, Angular. I am currently located in Jammu and Kashmir, and you can see on my profile about a little video about myself and also about my past experiences. I have worked in some of the big IT companies in India, and I have gained a lot of experience in all those IT companies. And I have worked as in like senior developer, technical lead, solution architect, and all those roles. So basically, I was giving you, so you can read more about myself, about what motivates me, about my past in on my LinkedIn. And agents, in other words, these can also be referred to as plugins. So an agent or a plugin, it is going to be very important with regard to interacting with an LLM, because an agent will there will be like thousands of agents, and therefore every task there will be an agent. So let me just give you a brief overview about, like, I thought it would be better that I will provide an overview of types of agents and how should we create our own custom agent, because till now we have been looking at the agents or the plugins which are provided by Langchain or Llama Index frameworks, but there might be some scenario or some use case where we have to create these agents on our own. Now let me give you an example. Suppose we have an we have a question, we have a requirement of we need to create an agent which will search our own database, or which will perform search, retrieval, or processing in our privately owned data store or documents. In that scenarios, we will make use of our own private agent. You can think this as to be an npm repository, because see, when the npm repositories came into picture, or when they were introduced like you have a node application, and you can use this npm repo or npm repository or npm library to perform any task in your repository or in your source code. For example, if you have to parse an xml to json, you can use an npm repository which is available on public npm repository, and you can access it and you can integrate it with your own source code and convert the xml to json. But there might be some scenarios where you will require a private npm package. So in that case, you won't host that npm package onto a public cdn or a public repository. Instead, you will keep that npm package, or in terms of .NET, we had this NuGet packages. So similar to that, we have a concept of plugins or agents. Now, we might want to create an agent which will do some private job and we won't share this agent to public on a public CDN or a public repository, and we only want to share this agent to our development team. In that case, we will require an agent, a custom agent to be built. Otherwise, there are a lot of agents, and each agent does everything we require. Like in terms of whatever is our requirement, we will find an agent which does that requirement. So I think agent is going to be a very important point, but please do remember that agent is like it is a concept which is still in experimental stage. So if you try to work on agents and if you try to create agents on open source, you will face some problems. And if you try to create or run agents on like OpenAI, ChatGPT, you won't face those problems. It all depends on the LLMs and the agent you are using and all those things. But still, the agent is or the plugins are still in the like experimental stage. So let's start with the concept of an agent. So we will have, let me just put in here, we will be discussing about agents. Now, this entire cycle starts with input. Like input is nothing but it is the question or it is the prompt which is going to be received from the end user. So the end user will interact with the agent through an input. So the end user, I'm just going to rename it to, just excuse me, I'm just going to change it to end user. Okay, so we have this end user, and end user is going to interact with our LLM or with our agent using an input. And this input, as I had discussed in my previous video, will be converted to a prompt. So we will have a prompt. So prompt will be, ultimately it will be using a prompt template. So if you are not aware of prompt and prompt template, I would highly recommend that you should watch my previous videos because I have explained by giving some examples about prompt and prompt templates. Now agent is going to receive this prompt. So what is an agent uh, in terms of us as developers? Agent is nothing but it is a part of the Langchain library. So Langchain provides us with agents, and we have predefined or we have custom agents. Now agent is going to receive this prompt, and agent will make use of like once it has received a prompt, it will forward this prompt to a set of tools. Now, this is a concept of agent. Now, there is a separate concept of tools. So we have tool one, we have tool two. Tool one can be search on Google, and tool two can be search on Wikipedia, and tool three can be search or perform some mathematical operation. So an agent will require these tools in order to perform any kind of action. Now, when a prompt is received to an agent and an agent has access to these tools, now what an agent is going to be doing is the agent will have an agent action and will have an agent finish. So we will have agent action and an agent finish. So once an agent receives a prompt, it can either perform an agent action, because this is something we had not discussed in our previous video, agent finish. So we have an agent action. So an agent can perform an action, or it can perform an agent finish, or it can have a final result and its work is done. So an agent can receive the prompt. It will either perform an action or it has performed an action and it has finished. So it can either be, let me just change this to here. So it can either, once it has received a prompt, it can send it to the agent action or it can perform an agent action. Either it can go to agent finish or it can go in a loop. So it can go back and pick some other tool and perform an action. And if it has found the results, it will call, or it will go to the state of agent finish, or this loop will continue. So let me give you an example in LLM terminology. So once we got this prompt, the agent will receive an input. The input will be like we can have an input saying that, let's think, finding finding a hotel and making a booking. So find a hotel and make booking. So we can receive this prompt, and this prompt will require, if we have passed this prompt to an agent, the agent will require access to the internet to find an hotel, and it will require some other tool to make a booking for that hotel. Now, that is where it will first find the hotel, then the agent action is performed, and it will check, have I finished the complete task? The complete task was find a hotel and make a booking. So I have only finished part of the task, that is find a hotel, and I still need to make a booking. So it will go back and it will check other tools, and it will pick the other tool and then execute it. And once it has executed it, it will call agent finish, and we will have the booking created. The hotel would be found and the booking would be created. So this is how an agent is expected to function. Now, when let me just color this part. All the boxes which I have, just a second, all the boxes which I have colored in yellow, these are actually managed by an entity called agent executor. So we have something called agent executor. So why I am explaining about agent executor is because once you like check the demo, or once you run the LLM code on your own, you will see this terminology, and then you should be aware of what an agent executor is and what it actually does. So everything what we have seen here, everything which we have seen, all these yellow boxes actually are nothing but this is agent executor, handled by agent executor. So this is handled by agent executor. So this is how an agent is supposed to function. Now, coming back to the next part, we will have to define, like, see, when we receive an output from a tool, there can be some issues with the output, or we might want to like parse the output in a certain format before we send the output as an input to the second tool. So let me give you an example. Now, if you want to if you are executing three tools, one by one or in a sequence, the result from one tool has to be passed or has to be stored in a specific format and then passed it to the tool second. So that is the job done by the output parser. So we have something called as an output parser. So what is the role of an output parser? So output parser will be responsible for, it will be responsible for like storing or parsing the output from each tool and storing it at a specific location. It can be a vector DB. We can store the output in a vector store, or it can be a document storage, like we can have the data stored in text, JSON, or CSV format. So basically an output parser is going to parse our output from each tool and store it, or we can use some other technique to storing it. We can only use output parser for parsing the outcome from each tool. Now this is one part of agents. Now coming to the second part, we will be discussing about types of agents. Now this is how an agent should function. Now, few years back, we had a document release called React Framework. And this is not the same React.js, but it is a React framework for defining agents. So what does this React framework mean? So we have this So it is actually written in this way. So we have this React framework. Now this React framework is defining how an agent should function. So in React, it means RE stands for like reason and ACT stands for action. So an agent should first reason and then it should perform an action. So that is what is meant by the React framework. This defines how an agent should function. First, an agent should reason and then it should like act on that reason. So we have like first it will go to this action, perform some reasoning, act on it, and if it has got the output desired, then it will finish. Otherwise, it will go in a loop. Now, with regard to agents, going to the second part of this video, we have agent. Agents can have different types. So first type of an agent is called zero shot React agent. So it is short agent. So it might seem a little confusing name, but let me explain what does this mean. So zero shot React actually means that when you are interacting with this agent, you don't need to provide the agent any training or any example data. You just pass in the task and agent will respond to that task. So it is like the agent is expected to know or have prior knowledge about the task. You can ask a question and agent will give you the answer. So giving you an example, suppose I ask a question to an agent, what is 7 divided by 3? So when I ask a question, what is 7 divided by 3? The agent will give me an answer, and that is called zero shot React agent, because I didn't have to pass an example or I didn't have to pass any training to the agent. I just asked a question and the agent responded with the answer. So that is what is a zero shot React agent. Now the other type of an agent, self ask with search agent. So we have self ask with search agent. Now this agent will require an access to the internet. So once you decide to use this agent, you will have to allow it to access to the internet. And once it has accessed the internet, in order to come to the final observation or final result, this agent is going to ask you questions to know more about the task. Suppose I am giving an question to the agent, but agent is not able to exactly know what I require or is not able to find the exact answer to my question on internet. So what will agent do? Agent will ask me questions to know more about what exactly I want. So this type of an agent is required if you don't have a clear understanding of what you actually want. So if you are trying to like ask a question which you are not quite positive about, or you don't know exactly like what you want, then you can use this type of an agent. But if you know exactly what you want, suppose you know that 7 divided by 3 is this, and you know that agent will once gives you the answer, you can verify it, then you can go with zero shot React agent. Then the third type of an agent is React document store. So this agent is going to be used, suppose you have a requirement where the information is not available on internet and you have the information stored with you privately on your CSV data or on JSON or on XML, then you can make use of this type of agent. So you can have this agent where you want to like want the LLM to search in your private data without accessing the internet. So these are three types of agents. There, I'm sure there will be some more types of agents, because this technique of agent or this technology of agent is rapidly increasing or rapidly changing, and like there are a lot of improvements or a lot of enhancements done each day. So this will definitely grow and change as we move ahead. So this is what I thought I should create a video where I should explain a little bit more about the agent in terms of how they work, what are they like, what are they comprised of, and also what are the different types of agents. Now, as it has been my habit that I have first shown an explanation and then come to a demo. So in this case, I am going to provide a demo on Kaggle. So if you are not aware of Kaggle, Kaggle is a very good frame, like it's a very good application owned by Google, and it provides you a very similar platform like Google Colab, where you can create your own notebooks and you can learn and uh, check machine learning or LLMs, open source or private LLMs. All these things you can perform in Kaggle. So when I have created this notebook on Kaggle, first I have installed all the libraries which are required, like Langchain is required because we are looking at a demo of Langchain agent. Then transformers is required for transforming our sentences to chunks. Then accelerate and bits and bytes is required. Then we are also going to require an experimental feature of Langchain because see, as I mentioned, agent is a very hot and new topic. So it is changing rapidly. So we need to use some experimental features which are still not available in the main library. Now, once we have installed these packages, then I'm going to log in to the Hugging Face Hub because this is required as I will be showing you a demo. By the way, this is going to be a demo of the custom agent. So I will be creating an agent of my own. In my previous video, I had shown you how we can use predefined like tools. We can create a array of predefined tools and then run that array and let the LLM pick the correct action and give us the result. But in this video, I am going to provide a demo of how we can create our own agent using LangChain for our own private or our own custom job or task. So for that, I will require an LLM, which is going to be our Llama 2 LLM hosted on Hugging Face. So I have logged in using the Hugging Face library. Once that is done, so this is our normal basic code which we will require to create an instance of LLM. So if you are not aware of this code, I have explained this code in detail in my previous videos where we are defining Llama 2 instance, creating tokenizer, creating the pipeline and then wrapping the pipeline inside Hugging Face pipeline, and we get an instance of LLM. So by at this point, we have the LLM which is loaded inside our Kaggle. Now we are going to execute this code. And let me briefly explain what this code does. In this code, I have created a custom tool. As I mentioned, we can create number of tools and each tool we have to pass to the agent. So I have created a custom tool which only checks for the length of a word. So it will take a word and it will return the length of the word, and the thing which makes this as a tool is this decorator which I have used @ tool which comes from Langchain agent. So right now I have not created any agent. I'm just creating a tool which is actually this. I'm creating a tool, and then once this tool is created, I will just test this function or this tool standalone. So I'm not going to, in here, I will not integrate it with the agent. I'm just going to run and check. And then I will create an array of tools. So this is an array of tools, get word length. It's an array of tools. And ultimately, I'm going to create a prompt. So the prompt is nothing but this is going to be this prompt which I'm going to create from a prompt template. So I have defined a prompt template. So I'm telling the LLM, so this is the system message for the LLM to understand or to have a context. So I'm telling the LLM, you are a very powerful assistant, but don't know current events. Okay, so this is the background. And then it is just a basic background which I'm providing to the LLM. And then the input question I'm going to ask the LLM is going to be sent to as an input placeholder. So once this input placeholder receives this question, it will be created as a prompt, and then we will bind it with the LLM which we have defined in our previous step here. So this is how we create tools, and this is how we pass the tools to the LLM. We bind them to the LLM. Now in the next step, these two statements are actually for Kaggle, so you can just ignore them. They are just here to fix the error which is specific to the Kaggle kernel. Now in here, I have used a private function create Python agent. So create Python agent is from the experimental feature of Langchain. And here I am only passing this tool, and we have the LLM instance. So this tool is basically for the agent to create like an terminal kind of a background, this Python REPL tool. Now I have passed a verbose true, which will like this. After I run this command, it will print a detailed like step by step of how it has executed the command or our prompt. Now this is what I had explained about zero shot React. So here we are telling the agent, or we are telling Langchain, that we want to create an agent of type zero shot React. Now, once that is done, we have created an agent, and remember that this agent is bound to the LLM, and we have just passed it as a REPL tool for it to have a basic terminal functionality. So that you can consider this to be another tool which is here. Now, once that is done, then we are going to ask it an question, which is going to be this question. So we are going to ask a simple question that convert this list into lowercase. So I have this list. So please convert this into lowercase. And once you have converted it, then sort this list. So it does two things. One, it converts it into lowercase, and then it sorts this list. And remember, this is going to be done by our custom agent, which we have created on our own, not any predefined plugin or agent. So once this is executed, so I was discussing about agent executor. So we have this agent executor, which I was discussing here. Once this agent executor receives it, it will show you some verbose data, and then it will show you the action. So the action is action input. It has understood that it needs to convert the list into lowercase. So it is very smart enough, the LLM, to understand that I need to use the function dot lower. So it has given you the outcome from the first action. So once you receive this observation, observation is nothing but the result from the tool. So the result from any tool will be shown to you as an observation, and like the input to the tool is shown to you as an action input. So you have an action input, and then you have the observation, which is the result. So it has applied dot to lower, and it has given you this. But then it is telling us, so the LLM is thinking that now I need to sort the list also, because I had said once you had converted this list to lowercase, then sort this list also. So then what it does is it also applies a sort function to it, and finally it sorts the list, and then it thinks, because see, then it comes to this stage and checks, have I finished? And it thinks, yes, I have finished. I have done the lowercase, I have sorted. So now let's go to the agent finish stage. So it has gone to the agent finish state, and it has given you the final answer. So the final answer is Alice, Bob, Charlie, and the input was this. So if I pass false here, verbose is equal to false, it will give me directly the final answer. It will not give me the call stack or call trace of how it has done it, what steps it has done, or what is the input, what is the observation. It will directly give me the final step. So this is an exciting video. I was very excited to look at the result. And the reason I'm giving you demos and everything on open source LLMs instead of ChatGPT or OpenAI is because I think I should be able to provide you something which you should be able to check on your own without paying to any third party. So that is the reason I try to use open source LLMs and open source libraries. So I hope you have liked this video, and I please request you to subscribe to my channel, because that really motivates me to create these videos, to create such videos, and do a lot of research before I create these videos. I look forward to meet you in my next video. Take care. Bye.